Okay, so in this first video, we're going to use the Seeing Theory website to simulate the central limit theorem. And let's see, so for starters, let's briefly refresh what the central limit theorem is. Right, so what this is stating is that if we have some population, in this case, this is this yellow area, this is what the population distribution looks like. If we have this population and we collect samples from that population, and so for each of those samples, we're calculating a sample mean, in the aggregate, those sample means will approximate to a normal distribution. And if this isn't making any sense, stay with me because that's the whole purpose of this visualization. So for starters, let's just get right to the gist of it, and then I'll back up and explain what's happening. So running a quick simulation here, we're seeing that we're developing a normal distribution. And so to kind of explain this interface and what just happened, we'll go through this step by step. So this here, like I said, is the population. And this yellow region, this yellow line and region, represents what that population distribution looks like. And then when we click sample, we see a bunch of these dots falling down. And those dots each represent individual participants, right? So they're part of the sample. So if we drop the sample size to 1, now we're seeing all these individual dots fall down. And draws represents the number of samples we're collecting from that population. More specifically, how many sample means we're computing, but you can think of it quite simply as the number of samples we're collecting. So if we have sample size 1, draws equal, let's say 5. Right now we only collected 5 samples and calculated those sample means. And then those sample means are falling down here to this. This is the sampling distribution. And you'll notice that now we don't have that normal distribution that we saw earlier, right? And that's the whole point of this. It's what we're trying to simulate when we talk about the central limit theorem, right? So in other words, when we have samples of sufficient size, right, we need large enough samples, then our sample means will approximate to a normal distribution, right? And so we can up the sample size and we'll see that line here is when I click theoretical. That's what theoretically the sampling distribution should look like, right? And so as we increase the sample size, we see that it's getting smaller and smaller, or tighter and tighter. It's less widely dispersed. The variance is shrinking. What's happening there is that as sample size is increasing, the standard deviations or variance of this sampling distribution are decreasing. And if you recall from the content in this module, the standard deviation of this sampling distribution is what we call the standard error of the mean, right? So as sample size increases, the standard error of the mean decreases, right? And so if we collect a sample size 15, draws equal 1, then I want you to think how many dots are going to fall down. And the answer is 1, right? Because again, the answer is 15, but we're only going to calculate 1 sample mean, right? And so let's do that. We see 15 dots come down, we're calculating 1 sample mean. And we can continue doing this over and over again. And as we do it, we see these proportions changing, right? Because those percents represent the percents of sample means within each area of this sampling distribution, right? And so when we do this step by step, we see that it takes us a while to get to anything that looks like a normal distribution, right? And that's because the central limit theorem is talking about this in the aggregate, right? And what the trends look like over time. So we can keep doing this, or we can just kick up the draws. In fact, that was too much. So let's just go to 2 for the sake of example. And so there you see, okay, now we drop down 2 sample means, right? Both the samples were still size 15, but now we have 2 means that are informing this sampling distribution. And so we can kick up the draws to, let's do 10 or 11. And so we can see we're getting more close, or closer, I guess, to that normal distribution in our sampling distribution, right? And so essentially this is visualizing what this central limit theorem looks like in practice. And so now let's change this population distribution. Let's go back to these parameters. And so we can kick up these parameters, alpha and beta. We don't need to worry about trying to discern what alpha and beta mean. The simple way to understand this is that it's going to change what this distribution looks like. And so I can go down here and I can make this wacky looking population distribution. And if I have a sample size of 1, you can see theoretically it's still going to look like that population distribution. Right, and so the point here is that when we're just looking at samples of size 1, those means are still going to look like the population. But if we kick up the sample size, again, just immediately we can see that the standard error is decreasing and we're starting to get closer to a normal distribution. All right, and so now let's do that. And we're calculating sample means. And sure enough, right, we're getting there, even though the population distribution looks completely different than it did before. Now let's change this to be a normal distribution, and now we can see an even smaller standard error down here, right, an even narrower sampling distribution. And then we collect our sample means, and sure enough, that's what we move towards. Right, and so again, I hope this is helpful to kind of visualize what we mean by this. Because again, we have population up here. Well, we can reset here. Our sample size, which represents how many participants or dots are falling down there. And then draws, which is the number of samples we're collecting. And so I encourage you to play around with this and maybe revisit this video if you need to. But play around with it, and hopefully that will help the central limit theorem kind of come to life a little bit and stick a little bit more in how this works. And again, I encourage you to play with the population parameters too, and change this shape. And notice that regardless of what this shape looks like, if we have a large enough sample size, then we're going to decrease that standard error and we're going to approximate to a normal distribution. And the larger their sample size, the narrower the narrower this distribution will be, meaning the smaller the standard error of mean is. All right, and yeah, I'll go and stop this video there. We'll see you in the next one.